All right, here's the spicy homework page. All right, so calculate the slope, show work, and write the math models. Okay, so for the red one, let's go 0, 2, and 2, 7. I guess looks pretty good. Okay, all right, so this is going to be for red. So it's going to be 7 minus 2 over 2 minus 0, which is 5 over 2. Is that the same as this one was? I guess it was. I guess I didn't change. Oh, I guess I didn't change the line for medium. Okay, so that's 5 meters in 2 seconds. Okay, so that's 2.5 meters per second. Okay, and it starts at a position of 2 meters. Okay, so XF equals 2.5 meters per second. That's the slope, times the X variable, which is time, plus 2 meters is the starting position. Okay, all right. And then for blue, all right, we're going to go 0, 6, and 4, 0. Okay, so I'll go 0 minus 6, and then 4 minus 0, so negative 6/4. So negative 1.5 meters per second. Okay, so for blue, XF equals negative, make sure you don't forget the negative, that's really important, times time plus 6 meters. Okay, so please make sure that your units and everything are in there, and that's all right. Okay, all right, at what time and position do they meet? So I can look right here and I can see that this happens at 1 second. Okay, and a position of 4.5 meters. All right, okay. All right, describe the motion of the object in as much detail as possible. Include at what times and position the changes happen and the velocities in each interval. Okay, all right, so the first one, let's see, it takes 2 seconds to go 2 meters. Put that over here. Okay, 2 meters, so that's going to be a speed of 1 meter per second. Okay, so the object starts at a position of 0 meters and moves in a positive direction at 1 meter per second for 2 seconds. Okay, then now it's going to go the other way. So let's see what's going on with this. This is going to be 1, 2, 3, 4, 5 meters, negative 5 meters in 1 second. Okay, so that's a velocity of negative 5. Then moves in a negative direction at negative 5 meters per second for 1 second. That's pretty fast. Okay, then stops for 2 seconds. Okay, then moves in a positive direction at, let's see, 1 second, 1 meter, 1 meter per second for 1 second. Okay. All right, what's the total displacement of the object over the first 6 seconds? Okay, so displacement, remember we're just comparing the final to the initial. Okay, so the final position here is negative 2 meters minus the initial position here, 0. Okay, so really this object only went 2 meters, right? Because if you look just from 0 to here, that's only 2 meters, negative 2 meters. Okay, the total distance we have to see. Okay, we're going to add up everything. So on the first one, right, it went 2 meters. Okay, then it went a distance of 5 meters, right? The negative, remember, we don't care about, doesn't matter. Okay, then plus, he didn't go anywhere during that part. Okay, and then the last part, he went another meter. Okay, so 2, 7, 8 meters total would be the distance. Okay, remember, you're just adding them up and you don't care about the negatives. Okay, rank the speeds. Remember, direction doesn't matter to the speed. Okay, so speed just means how fast. So the slowest he was going was during interval C, because he wasn't even moving. Okay, which was less than the next fastest one, okay, was A and D, right? Those were both moving 1 meter per second, so I'm going to put in equals, okay, which is less than B was the fastest. Even though it was in a negative direction, B was still the fastest at 5 meters every second. All right. Okay, think only about interval A. Would the graph of an object, what would the graph of an object that was traveling at the same velocity, well, I should have said look like or something, I don't know, you probably got the idea. As the object in this graph, but started at a different place, draw and explain, okay? So if it's going to be moving at the same speed, then it would have to be a parallel line. So it might look something like that to that, right? So if one of them just started in a different place, they would just sort of like keep the same distance between them, okay? So they would look like parallel lines, okay, if they were at the same thing. And then how would you know at what time they would meet? Okay, so if those lines are parallel, when do parallel lines cross? Never. They will never meet, right? If they are going the same speed and they start in different places, they're never going to meet. They will meet never. Okay? All right, so check that over and make sure you can do that. Did you have to write? Yeah, you had to write the math model. Okay.